Bismillahirrahmanirrahim. Good evening, guys. Today, our purpose will be to know how we can determine the focal length, but here in this week, we'll learn how we can do that to mirror, not lens. I mean, concave mirror, how we can use the focal length equation and how we can determine the same focal length by using graphical method, okay? Like the question says, determine the focal length to dental concave mirror. Here, not less, be careful. According to the column below by using the focal length equation and the graphical side. All of these two ways will be to the same result, and after that, we will do a simple comparison between them. Okay, here at this week experiment, we have so much similarities with previous experiments. I'm talking about the focal length equation will be the same, about the graphical method, how we will plot the necessary elements to can calculate the focal will be the same, but some important difference and simple difference will be, for example, the mirror. At the mirror, when I say mirror, that's mean we don't have any opportunity to escape light rays because the mirror will be from one side, from the other will be totally blocked, like my phone, like that. That means we have reflected rays. We don't have any escape rays. We don't have any opportunity to can see the rays from the back of any mirror. Okay, by that, the screen, the picture will be in front of the mirror. Here, it's different from the previous experiment when we was working on the lens, convex lens, because the screen, it was put after the lens, okay, because we was dealing with reflected rays. Here, the situation is different. Here, this simple picture illustrates to us the mirror here is in front of my mirror, okay? And no way we can put it directly between the mirror and the object or the light source, because if we put it that the situation, I don't have any opportunity to take reflected picture of this object. Why? Because the screen, when we put it between the mirror and the object or the light source, that means I don't have any rays reached the mirror, okay? Because the screen will act as a wall. It will prevent any rays from through to can reach the mirror. Okay, that means we will put this screen at some side near from the mirror to can take a specific picture with sharp boundaries. Okay, now U and V, the same thing with previous experiment. V, it was the distance between the object or light source to the mirror, and it was the bigger. And U will be the distance from mirror to the screen, okay? I am saying mirror in all of these two distance, U and V. When I say U, that means I have a mirror to something. When I say V distance, that means I have the same mirror with another thing. That means, let me use this picture to illustrate U and V, the distance between the mirror and the light source, and U is the distance between the mirror and the screen, okay? Always at this experiment at the previous one, V, it was bigger than U, okay? But here, it's a simple difference between them. At previous lecture, when I say distance, that means U plus V. But here, at the mirror properties, U is smaller than V. That's the same with the previous lecture. But here, when I say distance, that means distance equal V, okay? The distance between object and the mirror, that means it's the V distance, okay? We will use the same equation, reverse, inverse. Focal length equal inverse U plus inverse V. And by using this simple math equation, by saying UV, U plus V divided on UV, when inverse, the inverse F focal length will be U multiple V divided on U plus V. I think it's easier and it's clear, better than the first function. It's a little bit complicated because that I prefer to use this simplify, okay? This function. When I have U and V, that's mean I need U plus V and column and U multiple V column. You can calculate F to focal length to all of these five times, because we calculated U and F to 5 times to can reach better focal length result. Okay? U multiple V divided on UV equal, by that from 5 U and V results, that means I have 5 focal length results. Let's take a look to all of them. All of them are close to each other. That's mean our results are good. But we have one focal length to this mirror. By that, we must take a focal total divided on these 5 times. To be, I have the focal length to this specific mirror equal 10.7 centimeters. What that mean? Centimeter. That means after the center of this mirror, we can calculate 10 centimeters, and after that, we will say the converging points of these rays are converged here at this point, because that we say converging point. That means the converging point, it's after 10 centimeters from center of this mirror. Now, the theoretical side is done. Let's go to experimental side and do our comparison between these two results. Here at x-axis will be U plus V, at y-axis will be U multiple V. Sure, centimeters square, not just centimeter. Why? Because U unit is centimeter, V unit is centimeter. That's mean multiple between them will be centimeter square. And here just centimeter, because between them just plus. Here, let's set all of these number to can reach this slope. I selected these 2 points because these were the better, and by using it, I found the focal length equal 10. If I selected the other, for example, this point with last point will be more than 10. If I used one of these irregular points will equal 8.88. That's mean less than the expected value, because here in this situation, my focal length or the focal length of this mirror, I know it was equal 10. By that, these 2 results, it's the better, okay? Now we have enough experiment to can select which one will be the better, to can reach the best result. By that, the experiment results, it's close from theoretically result. By that, our work is done. We reached our goal. We do it. Now, at last step, let's talk about the conclusion, the relation between y multiple v at y-axis and u plus v at x-axis is a linear relation like we are seeing here. Linear relation, its kind is direct, and all of the experimental results and theoretical results are close from each other, and the focal length equal 10, or we can say 9.7. Sorry, here the experimental result was here 10. Yes. And at the theoretically, it was equal 10.7. Yes, that's right. By that, let's correct that. At experimentally, it was 10, not 9.62. Okay, be careful about that. Thank you about your watching your result and your listening. Have a good day and see you in the next video.